Okay, welcome to Unit 1B, Day 7, Part 2. So these are the word problems. So I just decided to make another video because these are a little different than the questions at the start of this section, which is all about finding the solutions to linear quadratic systems of equations. So we're trying to figure out where the line and the parabola hit each other. And a lot of times that is the sort of thing that will also help us solve word problems. So if I have two consecutive integers that are squared and the squares are added, their sum is 421. So when we set up a question like this, we have to define our variables. So let's start with, we could do x and y, but I get sick of that. So let's go, I don't know, s and t represent the numbers in question, and, or just numbers. And then we're going to come up with a couple equations. One is based on this here. When two consecutive integers, if they're consecutive, just a little trick here. Consecutive integers mean they're in a row, like 3 and 4, or 11 and 12, or whatever. So if x is my, sorry, I said I wasn't going to use x. I'm so used to it. If s is my first number, um, that means that S is one of my numbers. The other number could be T, which is one more or one less than S. Okay, so this is saying that I start with S, I start with T, I go up and I get S. Or vice versa, I could make this -1, I could put the +1 here or the -1 here. But I have two numbers that are separated by 1. Another way I could do it, I could just start it off by saying S subtract T is equal to 1, and then rearrange. I could do that. The other thing is, the other part of the equation here is that when these numbers are squared, so when what's wrong with me? S and T are squared and added together, so T squared plus S squared is equal to 421. And you could write S squared plus T squared, up to you. T squared plus S squared is equal to 421. Now I have this and I have this, equation 1, equation 2. I will sub 1 into 2, so sub 1 into 2. And then I have, no longer do I have s's, but I have all t's, so t squared plus s squared, which is now t plus 1. I can square that whole thing, is 421. Then I will FOIL this out. T plus 1 squared, that is going to be, remember that's a perfect squared. So I have t squared plus 2t plus 1. So this number is double this, and this number is square of this. If you want to take your time, go ahead and FOIL it out. But if not, you can use a little shortcut. That's 2t squared plus 2t plus 1 is equal to 421, plus 1 is equal to 421, and then I'm going to set this equal to 0, and we need that for when we solve. So t squared plus 2t, and I bring this over, so that's minus 420 is equal to that. Now, right away, I can look at this and say, look, I have a common factor into this equation, and that would be 2. So I could factor the 2 out and divide everything by 2, and when I do that, remember I can do that on this side, because I have 0 divided by 2 is just 0. So I can just common factor everything out, t squared plus t minus 210. So now I want two numbers that multiply to negative 210 and are 1 apart, different by 1. And you could go ahead and play around with that for a while, figure out what that is. And if not, though, let's pretend we couldn't figure out that they're 14 and 15. We could then sub this into the quadratic formula to figure out the answers. So A from here is 1, B is 1, and C is minus 210. Now, if you hadn't reduced here and you were stuck with these numbers here, 2, 2, and minus 420 as your A, B, and C, you'd still get the same answer, just your numbers would be a lot bigger as you went through. So when I sub that in, I get minus B is minus 1 plus or minus the square root of B squared minus 4 times A, which is 1 times negative 210. It's negative 210. The negative is going to be very important. All over 2 times 1. And that turns into 1, or minus 1, sorry, plus or minus the square root of 420. No, 400, I'm sorry, 400. I messed up. How did I mess up? 420. Did I mess up? 400, it's 410. No, I didn't mess up. No, I'm good. Okay, that's not 410. I did mess up. 420. There we go. No. Holy cow. It's Friday. Actually, it's Thursday, but it feels like Friday. 840. 4 times 1 times 220 is 840. Anyway, I'm going to keep going here. So I'm trying to get my answer here, and that's t is equal to all this stuff here. T is equal to minus 1 plus or minus the square root of 840. And I will just... Am I going to have to do this again? All right. I'm getting old. I really am. Enjoy your youth, children. What's wrong with me? 1 plus 840 is 841. Okay, so the square root of 841. All over 2. I think I just had a senior moment. My first one ever. Plus or minus the square root of 841, which happens to be, just off the top of my head, 29. No, I cheated. 29 all over 2. So I have two answers here. One is minus 1 plus 29 over 2. And the other is minus 1 minus 29 over 2. And that is what? 28 over 2, which is 14. So my t is 14. And this one is negative 30 over 2, which is negative 15. Okay, so my t's are 14 and 15. I want to find my s's, so I'll sub into 1 to find s. S will be t plus 1, so s will be 14 plus 1, which is 15. And on this side, I have s is minus 15 plus 1, which is minus 14. So I've been a big mess of everything. But my two answers are, if I had more room, I would write out my two answers are 14 and 15, or negative 15 and negative 14. Okay, so what I've done here is I subbed back into this equation here. You could have subbed into here, but that would have just made a big mess. So don't. Sub into here to find what s is. And again, we tend to find that our answers usually are either the same answer back and forth, or a positive version and a negative version of this, because at no point did we say that these numbers have to be positive or negative. Okay, so both these, this square this and square this, add them together, we get 421. Square this, we get 421. And 14 and 15 are one apart. Negative 15 and negative 14 are one apart. So that's that type of question. And I apologize for the numerous lapses in something. And then let's move on to an area question. So if I could find this question here. I'm capable of doing this? I think I am. Number 12. A rectangular field has a perimeter of 500 meters and an area of 14,400 meters squared. Determine the length and width of the field. Now, we usually start like this. Let L represent the length of the field, and let W represent the width of the field. Two things, they have a perimeter of 500. Remember that if we're going to have width and length, doesn't matter which way they go, it's W and W and L. So when we do perimeter, the perimeter is, we said, is 500. So equation number 1 is 500 meters equals L plus W plus L plus W, or 2L plus 2W. We're going to have to rearrange that in a second, but let's hold up. Number 2, area is this, so 14,400 is equal to the area, which is length times width. Okay, you can write that the other way around. LW is equal to 14,400. Now I need to write this in equation, the first equation, so that I have L equals something or W equals something. So I'm going to make it L equals something. L's over here, so I'll bring the W over. And when I do that, I get this. And then I'll divide both sides by 2, and you end up with this. L is 250 minus W. And I have no problem with you if you tell me off the bat, listen, perimeter is 500, which means L and W add up to 250, and then go straight to this. Okay, so again, we have this and this. We have one equation here. So this is my final number 1. That's my number 2. And I'll sub 1 into 2. And when I do that, I get 14,400 is equal to L, which is now 250 minus W times W. And when I multiply that out, it's 250W minus W squared is equal to 14,400, which gets me, rearrange this, bring the W squared over here because it's negative on that side, W squared minus 250W plus 14400 is equal to 0. Now I want to solve this equation here. This is a parabola. You're going to have whole numbers here, but these, I mean, two numbers are multiplied to 14,400 and 250 apart, or sorry, multiplied to 14,400 and add to minus 250. I know they're both negative, but that's a big number to deal with, right? So what I'll just do is go straight into the quadratic equation, which is going to then, and you know what, I'm running out of room here. That's b squared minus 4ac. Square root of that, add and subtract that from minus b over 2a. And I will do that without rewriting it. So a is 1 here, b is my minus 250, and c is this number here, 14,400. So I then have minus b, which then is minus 250, so 250, plus and minus the square root of b squared, which is again that minus 250 squared. The minus there, even though it doesn't matter when you square it, minus 4 times a 1 c 14,400 all over 2 times 1, or just 2, and that turns out to be 250. And when you play around with this, clean that up, you get this 4900, which might look like, you might know the square root of that, right? The square root of 49 is 7, and then this will be then 70. So I have 250 plus or minus 70 over 2, which leads me to 320. So I have the plus and the minus version. I have 320 over 2, which is 160, and on the other side I have 180. When I 250 minus 70 gets me 180 over 2, which is 90. If I go back and sub in here to figure out the other version, I go 250 minus w, so I'll go 250 minus 160, and that will give me 90. And you'll notice it's going to be the same answers here, 160 and 90. And if you do the same thing on the other side, you get 250 minus 90 is 160. So your length is either 90 or your width is 90, and then the other one is the 160. So the length and width of the field are either 90 and 160, or 160 and 90. Okay, so the same answer essentially in length and width. There's really no distinction between length and width normally. Okay, so that's it. Those are the word problems. Get to know those, and that's about it. All right, take care.